Today we're going to look at section 4.2, which is called logarithmic functions. So our objectives today, we're going to change from logarithmic to exponential form. Then we'll go from exponential form to logarithmic form. And then we're also going to graph log functions. So let's define what a logarithmic function is. It says for x greater than 0 and b greater than 0, with b not equaling 1, y equals log base b of x is equivalent to b to the power of y equals x. All right, the function f of x equals log base b of x is the logarithmic function with a base of b. Okay, so notice that we've talked about exponents in the past, and so anything that the exponent is connected to is considered the base. So notice that in our definition, b is the base, b to the power of y equals x. So notice that this base right here is also then the base over here when we're talking about it in terms of this log. Okay, so that base is going to be that little subscript next to the word log. All right. So, like I kind of mentioned, that little subscript b is the base, and it's in exponential form, the base of the equation. So notice that in log form, whatever the log is set equal to is then technically considered the exponent when it's written in exponential form. Okay, so that information is important when you're dealing with a log equation. The exponent term is not connected to the log. All right, notice that what that term x is, which is connected to the log, is what it equals when we're talking about it in terms of exponential form. So we're going to take these two things, and like our objective said, we're going to be rewriting them back and forth. So let's start with everything in log form, and let's rewrite it in its equivalent exponential form. So we're going to change it so then it's in terms of an exponent and we don't see the word log anymore. Okay, so what we're going to do is in this first example, if we have 3 equals log base 7 of x, we have to identify the base. So remember that little subscript there is always considered the base. So I'm going to start there. I'm going to start with the base, which is 7. Remember, whatever that log equals is the exponent. So I'm going to be going in this direction, heading to the other side of the equation. That's the exponent, so 7 to the power of 3. Then we're going to go right back to the other side of the equals, and then that's going to equal whatever the log is attached to is what the exponential form is going to equal. So 3 equals log base 7 of x. In exponential form would be 7 to the 3rd power equals x. And this would be my answer. Okay, they didn't ask us to solve anything. They just asked us to write it into exponential form. So we want to see that exponent. Okay, if we look at the second example, we have 2 equals log base b of 25. So once again, that little subscript there, that is going to be the base. So we're going to start with the base. So we would start with b. Then I'm going to go to the other side of the equal sign. So in this case, that's 2. That is going to be my exponent. So b squared. Then we'll go right back around to the other side of the equals. And in exponential form, now that's going to equal 25. So b squared equals 25 would be the equivalent exponential form. Okay, notice that in this example, log base 4 of 26 equals y. Once again, I identify the base of the log. It's the little subscript. That's what I'm going to start with. So 4 is my base. Then what I want to do is I want to go to the other side of the equal sign. So notice that for us, that would be the y. That's going to be our exponent. We'll circle back around to the other side of the equal sign, and then whatever is attached to the log is what that exponential form is going to equal. So 4 to the power of y equals 26 would be our equivalent exponential form. All right, now let's go the other way. Now let's start with exponential form and let's write it in its equivalent log form. So just like we did with the logs, I want to identify the bases first. Notice that 2 to the power of 5 equals x. 2 is the base. So I'm going to start it off by saying this is log base 2. So notice that my 2 is a subscript. It's small. Don't make it as big as the word log because that's not going to be an equivalent form. So make it a little subscript. Okay. Remember, I want the exponent to be on the other side of the equal. So for my exponential form, just like what we did when we started with logs, I want to head towards the other side of the equals. That x is what I want to have attached to this log base 2. Then I'll swoop right back around to the other side of the equal sign, and the exponent is what that log has to be set equal to. So log base 2 of x equals 5 would be our equivalent log form. Problem number 2, we've got b to the third power equals 27. So once again, identify what the base is. So in this case, our base is b. So I want to start it off as log base b. Then I need to go to the other side of the equal sign. That is what's going to be attached to our log base b. Then I go right back around towards my exponent. That's what my log is going to equal. So log base b of 27 equals 3 would be its equivalent form. And then in this one, we have e to the power of y equals 33. So once again, the base is going to be identified first. For us, this is e. So I'm going to say that this is log base e. We'll swoop around to the other side of the equal sign. That's what's attached to our log base e. And then we want to set that equal to our exponent, which is y. So log base e of 33 equals y is the equivalent log form. Okay, so you guys tried these checkpoint problems. So pause the video. You got 2 problems where you need to write the log form into its equivalent exponential form. And then for 2 more examples, you're starting with the exponential form and writing it into the equivalent log form. So hopefully these are what we got. So in number 1, we should have had 2 to the power of -4 equals 1/16. Number 2 should have been b to the 11th power equals 50. Number 3 is log base 7 of x equals 3. And number 4 is log base b of 22 equals 6. So hopefully we are starting to feel comfortable writing back and forth between these 2 forms. That's going to be crucial in a later lesson. All right, now let's talk about the graphs of exponential functions. Not exponential, of logarithmic functions. A logarithmic function is the inverse of exponential functions. So that's why we practice how to graph exponential functions in the first section of chapter 4, because we need to know how to graph exponential functions to help us with logs. So this means that the log function, remember, to be an inverse, we are going to be reversing the ordered pairs or the coordinates of the exponential function. It also means that the graph of the log is going to be reflecting over that line y equals x to be then an inverse of the exponential function. All right. So let's take a look at this example. We are going to graph f of x equals 2 to the power of x, and then g of x equals log base 2 of x on the same graph. Okay, so let's start with our exponential form here. So if we've got f of x equals 2 to the power of x, I'm going to make a table of values. Remember, exponential functions don't have any restrictions on our domain. So -2, -1, 0, 1, and 2. I can pick any number to plug into my exponent. So I'm going to have 2 to the -2nd power, which will really give me 1/4. We'll have 2 to the -1st power, which is 1/2. 2 to the power of 0 would be 1. 2 to the 1st power is 2, and 2 to the 2nd power is 4. So those are our ordered pairs. Remember, when I don't see anything being added or subtracted onto that exponential term, that means that we don't have any shifts. And so that means that our horizontal asymptote is going to be that y equals 0. So remember, we're never going to touch or cross that x-axis here. When I plot my points, -2 1/4, so super close to that x-axis, -1 1/2, so a little bit higher, 0, 1, 1, 2, and 2, 4. We will have something that looks like this. I'm going to label it f of x. Okay, so then remember, if I now want to graph the log, we'll notice that the log has base of 2, and so does my f of x. So that's what's going to make these inverses. They have the same base. So for the g of x function, we don't have to create a table of values because since we already have the table for the f of x function, all we have to do is flip the ordered pairs around. So I want to start with a 4th. That takes me to -2. Then we'll have 1/2, which takes me to -1. We'll have 1, which takes me to 0. 2 takes me to 1. And 4 takes me to 2. So those are my ordered pairs. Let's plot those. So notice that we have 1/4. So super close to that y-axis down at -2. We'll have 1/2. -1. Oops. Then we'll have 1, 0, 2, 1, and 4, 2. So notice that, because we're going to have the inverse of that exponential function. Remember, with my exponential function, I'm never going to have a value of 0 for the y's. Well, if I flip it around for this log function, that means I will never have a value of 0 for my x's. Okay, so notice how that's why with this g of x, it's getting closer and closer and closer to that y-axis, but it's never going to touch or cross. Okay, that means that we actually have a vertical asymptote here. Okay, and also notice that we could graph this where, remember, it's going to, since it's an inverse, it's going to reflect over that y equals x line. So notice that here's my y equals x line. If I was to fold one graph over the other, it would very nicely fold one on top of it. So I know that I graphed it correctly. All right, so we'll talk more about the vertical asymptote aspect of that in a later lesson, but go ahead, pause the video, and try graphing f of x equals 3 to the power of x, and then g of x equals log base 3 of x. Notice how they are inverses because they share the same base. Graph them on the same graph, please. All right, so notice that I started with my f of x, created my table, and then I just flipped the ordered pairs around to get the g of x. I should have labeled my graphs. I would really like you to do that, please. So you should have labeled f of x, and you should have labeled g of x, so we know which one is which. All right, but there are my two graphs. Okay, so that's us changing back and forth between exponential and log form, as well as graphing log functions.